Okay, I'm going to do the final exam review study guide. This is a long study guide. I don't know how many videos this is going to take. So we'll just see how it goes. Okay, so starting with scalars and vectors. Remember, a scalar has only a magnitude or a number value, and a vector has both a number value or magnitude and a direction. So we're going to go through and look at these things here. So things that we know are scalars. Mass is a scalar. That's just a number in kilograms. Speed is a scalar. That's our distance over time. And that's just a number. That's like if you read the speedometer on your car. Distance is just a number for how far you went. No direction in that. Time is a scalar. Technically it's a scalar. Minus 25 degrees Celsius is going to be a scalar because that is just a number we read off of a thermometer, even though it has a negative sign. Let's see, 36 meters per second would be a scalar because there's no direction information there. Things that are vectors. Velocity has a value and a direction. Displacement has a value and a direction. 45 miles per hour south, there's a clue word right there for direction. That's going to be a vector. Minus 9.8 meters per second, that's our acceleration due to gravity. The minus tells us the direction, that it's a downward direction. Acceleration is always a vector. So this one's going to be a vector, and the negative tells us that. Momentum is a vector because it's mass times velocity. Force is a vector because it's always got a direction that it's acting in. And then we just said acceleration was a vector. Acceleration is change in velocity. Since velocity is a vector, that makes acceleration a vector too. Okay, vector math. So you're hiking in the park. You go east for 5 kilometers, and then you realize you left your lunch, and so you go back west 4 kilometers so you can get your lunch. So what was your distance and what was your displacement? So your distance is just going to be the total amount you walked. You walked 5 kilometers, and then you walked another 4. So that's 9 kilometers total. Distance doesn't care about direction. Displacement is my difference between my starting and my ending point. So I walked 5 kilometers east, then I turned around and came back 4 kilometers west. So my difference between my starting and my ending point is going to be 5 minus 4 because I went in a positive direction, then I turned around and went in a negative direction. And that's going to give me 1 kilometer, and I'm going to be east. See, this was my starting point. I went east, then I came back west, but I'm still east of where I started. And that's what displacement tells us. Where are we relative to our starting point? All right, now we're going to go hiking again. We're going to go east for 4 kilometers. And then we're going to go south for a kilometer. So you notice here, these two vectors are not on the same line like these were. These are perpendicular to each other. So that means we've got to use the Pythagorean theorem so that we can get that, our displacement, our difference between our starting point and our ending point. Okay. So over here it says calculate your distance traveled. So distance again is just going to be adding everything up. We've got 4 kilometers plus 1 is 5 kilometers. Okay. Our displacement we have to get from the Pythagorean theorem. So we're going to use a squared plus b squared equals c squared, where my A, we'll call that one A, we'll call this one B. Those are my sides that are on either side of my right angle, my 90-degree angle. C is my hypotenuse, and that's what I want to solve for. Okay, that's what we call a resultant in physics. That's the result of us adding these two vectors. Okay, So we're going to have 4 squared plus 1 squared equals c squared. That's going to give me, let's see, 17 equals c squared. And then where's my handy dandy calculator? In order to get c, I've got to take the square root of 17. So that's going to give me 4.1. Okay. So I'm going to write that over here. C equals 4.1 kilometers. So that's my difference between my starting and my ending point is 4.1 kilometers. And I traveled east and then south, so I'm going to call that southeast. Okay. All right. You walk around a track that's 400 meters long, ending up where you started. Okay. So your distance traveled is going to be the 400 meters because you went around this track that was 400 meters. But displacement is the difference between our starting and ending point. And so if we ended where we started, our displacement is actually 0. That's just one of those weird things in physics, is that you can walk a whole long distance, but if you end and you in the same place you began, if you make like what we call a round trip, then your actual displacement, your difference between starting and ending point, is going to be 0. Now you walk around a path that's 250 meters long. It takes you 125 seconds. So your average speed is going to be distance over time. And that's going to be your 250 meters divided by 125 seconds. Okay, so that's the total distance you traveled divided by your total time. 250 divided by 125 should give me 2 meters per second is my speed. Your average velocity, okay, because you made a round trip again here. So your average velocity is actually going to be 0, because even though you took 125 seconds to make a trip, your displacement here was 0, your difference between your starting and your ending point. So velocity would be like basically your starting point minus your ending point, which are the same. So start point minus end point divided by time, that's going to be 0 meters per second if you have a round trip, because you ended in the same place you started. There's no difference between your starting and ending point. Okay. Okay, I'm going to stop this video so then I can pick up with graphs in the next one.